Hi everyone, this is Infinity YouTube channel. Please remember to like, subscribe, and share. Alright, today we are going to work with hypothesis testing. So in hypothesis testing, we are going to make some certain assumption. So we know that for us to come to a conclusion, some assumptions has to be made. So in testing of hypothesis, we are going to make some assumptions so as to come to a conclusion. All right. So in hypothesis testing, there are some things that we need to know. So the first thing that we need to know is what we call the null hypothesis. So the null hypothesis is actually a claim that the parameters or the mean parameters is true unless it is proven false. That means is an establishment that the parameters given, that the mean of the parameters given is true. So even though it might be false, so it has to be true unless it is proven false. So the next we have to also consider is what we call the alternative hypothesis. So in the alternative hypothesis actually is a hypothesis that may alternate what the null hypothesis was proven to be. That means in the alternative hypothesis, either you prove or disprove your null hypothesis. So there are various procedures that one must take, that one must know while doing hypothesis testing. So the first procedure that one must know is one, you must establish your null hypothesis. Your null hypothesis must be established. So your null hypothesis, how do you establish your null hypothesis? Null hypothesis is actually referred to as H0. Okay, we use H0 to represent our null hypothesis. So to establish that, we assume that the mean are equal. That means the mean is equals to mu naught. This mean equals to mu naught means that both of them are equal. So we are going to assume that this is true unless it is proven false. So the next procedure you have to take is the alternative hypothesis. You have to establish your alternative hypothesis. So establishing alternative hypothesis means that alternative hypothesis is actually called the code is called H1. We use H1 to represent alternative hypothesis. So to establish that, either we say that the mu1, that means the alternative mu is less than mu, the main mu from your null hypothesis. So during the alternative hypothesis, we will check if the mu1 is less than the mu from your null hypothesis. If it is actually less, then we call this a left-tailed test. Left-tailed. And this left-tailed is negative on your Z table. So the next you have to establish is, under this alternative as well, is mu1 greater than mu. So when the mu1 is greater than mu, then we call that a right-tailed test. Right-tailed. So for this right-tailed, it is positive on your Z tabulated. All right. So let's continue. So now when you've established these two procedures, then you can use that to determine your Z tabulated. So the next, after you determine your Z tabulated, the next you have to do is to determine your Z calculated. Or you can calculate for your Z. Okay? Then after you've calculated for your Z, you now establish either to accept or reject. Either to accept or reject the null hypothesis. So now for you to accept or reject the null hypothesis, if your Z calculated is greater than your z tabulated. If your z calculated is greater than the z tabulated, you can see we do not reject. We do not reject the null hypothesis. But if otherwise, you can see we are going to reject the null hypothesis. Now, graphically, you can represent this as, okay, so this region is going to be your left tailed, this region is going to be your right tailed. So let's call here minus z alpha over 2. Let's call here z alpha over 2. So this region is called your critical region. It's called your critical region. This region is called your critical region. Then this region is called your acceptance region. This is your acceptance region. Now, under this procedure 3, how to calculate for your z calculated is actually equals to x by x minus mu is divided by sigma divided by root of n, where sigma and n are the standard deviation and the sample size respectively. Then x is your sample mean, and of course mu is your population mean. So we are going to solve through an example, and then we'll see how we can utilize all these processes. All right, so I have an example here. So this example says that, I have an example here, and this example says that the quality assurance manager of Infinity Paint, claims that a particular brand of paint has a mean life of 65. So we are going to take it one step at a time. So solution, let's just continue down here. Solution. So he claims that means the mean life is 65. So this claim is actually your null hypothesis. Are you there? The claim is going to be the basis of your null hypothesis. So now we can see that we are going to take everything one step at a time. So we can see that our null hypothesis now, we can say that our null hypothesis, which is H naught, is established as mu equals to 65 months. Mu equals to 65 months. So let's continue. All right. Now, they say the Standard Organization of Nigeria wants to confirm this claim. In the confirmation process, they took 36 gallons. That means, let's just write it here. That means N, the sample, is 36 gallons in number of the set pairs for analysis. Their findings revealed that the mean price for paint is 63.75. So that the mean is 63.75. That means that the alternative hypothesis now is 63.75. So we are going to establish our alternative hypothesis. So to establish this alternative hypothesis, is we are going to assume that H1, the alternative hypothesis, this mu1 here is the proposed one, okay? The one that was now opposing, either proposing or opposing the null hypothesis, and which is 63.75. So is 63.75 greater or less than 65? Of course, it's less than 65. So we can say that H1, we can say under H1 that your mu1 is less than 65 months. So since it's less than 65 months, of course, this is a left-tailed test. This is left-tailed. All right. So the next we have to do is we are going to use the necessary values to establish the next question that we have. Okay, so we've done the first procedure and the second procedure. All right, so the next we are going to do is we are going to establish our z tabulated. Now from the question so far, it says that from the information available, can we conclude that the mean price is less than 65 months at 2.5% level of significance? So now let's look at this. This is 2.5 level of significance. That means alpha is already given. Then alpha here, it means that since alpha is now given, that means alpha is equals to 2.5%, which is same thing as 2.5 divided by 100, which is equals to 0.025. So we are going to go to our table, either your z table or your t table, which I have explained in the previous video. If you should do that, the z of 0.025 is going to give us 1.96, right? So the answer is going to give us 1.96. So is it going to be negative or positive? Since it is a left tail test, it's going to be negative. That means our z now is minus 1.96. So from our procedure again, the next we have to do is to determine our calculated z, right? So we are going to determine our calculated z. So our calculated z now is z calculated now is equals to by x minus mu divided by sigma over root of n, where n is equals to 36, sigma is equals to 4. So we can further say that by x is 63.75 and mean, which is the original point month, was 65, divided by 4, of course, divided by root 36. So if you should press that in your calculator, you are going to arrive at your z calculated now. You are going to arrive at your z calculated to be minus 1.874. So you are going to arrive at minus 1.874. So from here, we can see that our z calculated is greater than the z tabulated. Hence, we do not reject the null hypothesis. Okay, so that is how to answer the A part of the question. Now the B part says if the test is carried out at 5% level of significance, what will be the new conclusion? So what we'll just do on the B part now, is they said if alpha is 5%, not 2.5% this time. So 5% now is 5 over 100, which is 0.05. So we look up on our z score. Z of 0.05 is equals to minus 1.645, right? So just check 0.05 on your z score. So you can either use the both method as well that I've taught you in the previous video to look at this value. All right, so now from here now, they said if the test is carried out, so what will be our conclusion? So since we have minus 1.645, is minus 1.645 greater than the calculated value, or is it less than? So of course the tabulated now is greater than from the B part now, the Z tabulated is the one greater than the Z calculated. Hence, we are going to reject. We reject the null hypothesis. We reject H naught. Okay? We are going to reject it because the Z tabulated is greater than the Z calculated. All right. So the last but not the least in our question is, they said, is the findings of A different from B? Is the findings of A different from B? Okay. Judging from what we've solved, we can see that A and B are quite different. A and B are quite different. They are quite different. A and B are quite different. As you can see, in A, we rejected. In A, we did not reject. We did not reject the null hypothesis. We did not reject the null hypothesis, which is called H naught. Then in B, we rejected the null hypothesis. So this is how to analyze questions on testing of hypothesis. So one may have asked, why didn't I divide this alpha by 2? Of course, we are not looking for an interval. We are just looking for a particular number that will give us the Z. Are you there? Not like the previous previous videos that we did that we had to divide by 2. So just look critically on the question and you see clearly that we are not working with Z alpha over 2. So I hope this video was useful and helpful. Please remember to like, subscribe, and share. Thank you.